Hello everyone. In this video, we are going to discuss about few problems in the chapter 1 and 2. Okay, so these problems are very important. By looking, these are very simple and very important even for the competitive examinations also. Now we'll see those problems. Okay, so the problem is which one of the resistor circuits as shown in the figure below has bigger resistance. So the figure it is given. In this figure we have four circuits. So out of four circuits, which one is having more resistance? That is the our objective. We need to find which circuit is having bigger resistance. Okay. Now we'll take individual circuits, circuit A, circuit B, circuit C, and circuit D. All the values we'll find, and then we'll compare all those resistance values. Finally, we can say which circuit is having bigger resistance. First, we will see the first circuit, that is circuit A. So, in this circuit, we have total four resistance. You say R1 because all the circuits are having four resistance only. R1, R2, R3, R4. So these R3 and R4 are connected in parallel. So you need to find out first equivalent of this, and then whatever the value you are getting, so that it is in series with these resistance. First you find out the parallel resistance here, and then combine this one series, we will get the equivalent value of this. How it is, you see here in this, now you can see we have the four resistance R1, R2, R3 and R4. R3, R4 are connected in parallel. The equivalent of this, it is a 6 into 6 plus 6 plus 6. That is a 3. Either you can use, this is general formula. If it is only two resistors, directly also we can find. That is R1, R2. So here it is R3, right? R3, R4 by R4, R3 plus R4. We got the R3 ohms resistance. Then after finding the value of that, this is the R1, R2 and this is the R3, 4, right? Equivalent of this. So these three are connected in series. So how to find out equivalent of that? It is a summation of all three resistance R1 plus R2 plus R3, 4. That is this. So how much you got? This is a 2 plus 2 and this is 3. So 2 plus 2, 4 plus 3, 7 volts. This is the first circuit as total value is 7 ohms. Similarly, we need to find the remaining circuits. That is second one. We'll see the circuit here. Now we need to find out circuit B resistance. In the circuit B resistance, you can see again you have four resistance only. R1, R2, R3 and R4. R2, R3 are connected in series, and that it is connected with the parallel with the R4, 8 ohms resistor, right? First we will take the series part here. So these two, so addition of this and then these two parallel, we'll find out, and then again it is series. We'll take three steps here we need. That we'll see here in this. You can see now this is R1, this is R2, R3, R4. These two are connected in series, that is 4 plus 4, 8. Again 8 into 8, these two are parallel, right? So 8 into 8 by 8 plus 8 will get 4, 64 by 16, that is a 4 ohms. So 2 plus 4, that is total is 6 ohms. In this way you have to, this is the steps. If it is suppose, if it is like single mark or 2 marks question, directly we can give, if it is multiple choice, directly you can say here 2 plus these two, 8, 8 into these two are parallel, right? 8 by 8 plus 8. Directly we will get that is the value. If it is like a subjective type, we need to elaborate in this way. Okay. Now we will go for the third section, that is section C, that is circuit C. So in that circuit, we can see here is the circuit. Okay, so here what is there? First three resistors R1, R2, R3 are connected in parallel, and R4 is connected in series with this. Right? First these three are connected in parallel, so we'll take here. So 1 over R1 plus 1 over R2 plus 1 over R3 equal to 1 over R1 to 3. That is the equivalent of 3. Okay, so that is equal to 3 by 9. So R12 is equal to 9 by 3 equal to 3 ohms. So 3 ohms plus 2 ohms because these two are connected in series. So equivalent is 3 plus 2 is 5 ohms. We got 5 ohms in this circuit. Now last circuit we'll see, that is, here you can see the last circuit. Here what is happening? So these two are connected in parallel and these two are connected in parallel. So first we need to find out the equivalent of this and then find the equivalent of this. After that we add these two because these two are connected in series. Okay, that you can see the steps here simply. You see here R1, R2, these are connected in parallel. So that is a 10 into 5 by 10 plus 5, either 50 by 15, or if you are taking this way, that is a same value. Answer is same only, 10 by 3. 10 by 3, 50 by 15, so 10 by 3. So then after finding the value here, again you find this one. So what is the equivalent value? You will get 1 only. 2 into 2 by 2 plus 2. So 4 by 4, that is a 1 ounce here. Okay, now we got this equivalent and this equivalent. Addition of these two, R12 plus R34, because these two are connected in this one and this are connected in series. So 10 plus 3 plus 10 by 3 plus 1, that is 13 by 3. So that is equivalent to 4.3 ohms. Now we got all the values, right? R1, R2, sorry, first one, circuit A resistance, circuit B resistance, 3, circuit C resistance and circuit. So this one it is 7 ohms and this is a 6 ohms and then 5 ohms, right? And this is the 4.3. So which one is having bigger resistance? Circuit A is having bigger resistance. Okay, that is this. So that is the answer. Answer A. That means circuit A, this circuit is having, this one is having bigger resistance. Okay. Now we have seen this is the only resistance. In the next problem, we'll take similar type of problem, but the objective is different here. That how we will see here in this problem. So which one of the electric circuits as shown below has bigger current? So previous problem we have taken, that is the bigger resistance. Now we need to find out the current among the all four circuits. Now you see here we have four circuits A, B, C, D. Now we need to find out all four. Now we will take again here also we are having all the three elements R1, R2, R3. But they did not give any value. That's the reason what we will take here. So all the values for simplifying the calculations, we'll take the R1 equal to R, R2 equal to R, and R3 equal to R for all the cases. Okay. After that, first when you are taking first figure, figure A, all three resistors are connected in, these three are connected in series. So what is the equivalent value of that? Addition of this, right? So 3 into R, R plus R plus R, that is the value of this. That is the first one you can see. All are connected in series, so equivalent of that is 3R. Now, but our objective is current, right? So what is the current? We have to use Ohm's law. V equal to IR. So I equal to V by R. So V, you assume that it is a V. It is V. So V by R. What is R here? That is RA, circuit A, right? So RA equal to 3R. V by 3R. You see here? That is a V by 3R. One third into that times of V by R. Now we will take the second picture, that is this one. This is the second picture, right? All three resistors are connected in parallel in this case. So at that time, how we will take? Already we know last problem also we have taken see parallel connections. Just you need to take R1 over RB equal to, because B means here B circuit. 1 over RB equal to 1 over R1 plus 1 over R2 plus 1 over R3. You see here, that is only 1 over R P equal to 1 over. So 1 over R plus 1 over R plus 1 over R. That is 3 by R. Okay, so Rp equal to R by 3. So what is the current here? Again by using Ohm's law only, I equal to V by R. So V by R by 3. So 3 times of V by R, that is this. So simplest, that is a V by RP, V by R by 3. So it comes here 3 times V by R. That is the expression. You see here. So that is the expression. Okay. Now we'll see another two circuits C and D. Okay. In this case, what is happening here? So two resistors are connected in parallel, or second one and third one. In the fourth case, that is the first two are connected in parallel, right? So we'll see the first one here. Again, same circuit total I mentioned here for your understanding only. What is happening here? Okay, so in this case, R it is the first one, and two are connected in parallel, R into R by R plus R, 2R. What you will get here? R by 2. That is the value here. That is only here I mentioned. R into R by R plus R equal to R square by 2R. R cancel, R by 2. That is the equivalent of this, right? So R by 2 plus R. Okay, so total value of this, it is a R plus R by 2, 3R by 2. So once we are getting that, what is the current here? I equal to V by R, V by R, RC. What is RC? This is R by 2. That is R plus 2 plus R, right? 3R by 2. Now we'll see this one. So this is 3R by 2. So what you will get? 2/3, 2 by 3 into V by R. That is the current in this case. Okay. Similarly, we'll see the last figure, that is a figure D. It is also similar to this, but only difference is, so first two elements are connected in parallel. Again, you will get the same value here, that is a R by 2 equivalent of this plus R. Again, it is a RT equal to 3 times R by 2, right? 3 by 2 into R. So this is RD. How to find out current? Again, you have to go for this V by RD. So that is V by 3R by 2. Same value only here. 2/3 of same value. Whatever you are getting here, you will get the same value. Right? Now you see here A, B, C, D, all the four circuits. Which one is having more? Tell me. That is a circuit B. This circuit, this one, what is the current here? 3 times. 3 times 7. Right? So this is having 3 into V by R. Remaining all the case, here you are taking these two are 2 by 3. 0.66, right? First one it is 1/3 only, but second, this figure it is having more current, bigger current. Okay, answer is circuit B. Now I am giving one problem to you. Kindly solve this problem in the similar of second problem. It is almost same, but only difference is here I have given the values. Okay, so all the four circuits, again you need to find out which one of the circuits as shown below has bigger current. Okay, so all the values they have mentioned, voltage and resistance. Here this is a message here, you take just it is a 2 ohms. Okay, this one you assume that it is a 2 ohms and then find the value. So find out the current value, which circuit is having more current, that you find out. Practice the problem. Okay. Next, here I am taking another problem, that is how to find out electrical energy in the capacitor circuit. It is a purely capacitor circuit. It is given. Okay. So how to find out this capacitor circuit? Okay, electrical energy. You know how to find out electrical energy in the capacitor circuit by using half CV square. If it is a inductor circuit, half Li square, right? So, what you have to take here? First, observe the circuit. What are the values? Knowing values, that is a given data, and unknown values. Unknown values find the electrical energy. Knowing values, all capacitors are given and voltage is given. If you find the total capacitance of the circuit, so you'll get C, and we know from the problem, that is a figure. So half CV square we will get the electrical energy. Okay. Now you see in this circuit, so here it is given these three are connected in series and these two are connected in series. After finding the equivalent of this circuit A, now we assume this is circuit A and circuit B. So this circuit all are connected in series, find out the equivalent value and then find out the equivalent of this. After finding this, these two are connected in parallel, add this, so you will get the total value. That is the first step we have to go further. After finding that, use the electrical energy formula of CV square, then find the electrical energy in the entire circuit. Now we will see these are the given data, known values, all the capacitors C1 to C5, because 5 capacitors are there. Assume this is the first one, C1, C2, C3, these three are connected in series, and then C4, C5, these two are connected in series. First you take only this one, find out the value, because difference between resistor circuit and capacitor circuit is there you are taking whatever principle you are using the parallel, that it is useful for the series in the case of capacitor circuit, that we have to use. That is only what we are taking. 1 over CA is equal to 1 over 4 plus 1 over 6 plus 1 over 12. Now you see that, that is. After that, take LCM, find the value of CA. CA is equal to 12 by 6, that is nothing but 2 microfarads. This is the first part. Coming to the second part, again similar way, because these two are connected in parallel, sorry, series, but we need to use this formula. That is, either you can take 2 into 2 because only 2 capacitors, 2 into 2 by 2 plus 2, you will get 1 microfarad. Or you can take 1 over 2 plus 1 over 2. In that way also you can find 2 by 2 equal to 1. Similar way you can find out. That's it, this. You see in that circuit, second part we are finding here. CB equal to 2 by 2, that is 1. Now, after finding you got CA and CB. These two are connected in parallel. So, in the case of capacitor circuit, if these two are connected in parallel, then the equivalent value is summation only. Okay, just it is a reverse of the resistors and inductor circuits. Okay, now we need to find out total value of capacitance for this circuit. C is equal to CA plus CB. Now you see that. So that is a 2 plus 1, 3 microfarad. Micro means 10 power minus 6 farad. Okay, this is then, but this is the only off portion. But our main objective is you need to find electrical energy. So we know the value of voltage, it is given in the problem, and capacitance just now we found. So substitute these two values in the expression, that is of CV square. Okay, that is only electrical energy in the capacitor of CV square. Substitute and simplify this. So of C value, this is the C, and V square 40 square. So after simplifying, you will get 2400 into 10 power minus 6 joules, that is right. So 2.4 into 10 power minus 3 joules, or you can say that is 2.4 millijoules. Okay, that is the unit for the energy. In this way, we need to find the electrical energy. So in this, we have taken three different problems. One case we have taken all the circuits, which one is having more resistance. Second problem we have taken, so which circuit is having more current And this problem, it is we have taken how to find the electrical energy in the entire capacitor circuit. If it is a similar type, that is inductor circuit, similar way, but only thing is that is in magnetic field of Li square you need to use. You need to find inductor value, and then you need to find the use the current of Li square. Then you can find of Li square the energy in the inductor. Okay, so thank you for listening.